So yeah, thanks for the introductions. Yeah, so I think Daniel Tan here, based out in Singapore, right? So I basically lead the solution engineering team across the Southeast Asia and Korea, and definitely for Philippines is one of our largest and also a very successful market as well, right? And of course, today I'm here to talk about the few things that we are looking at, right? So everybody talk about AI and ML, right? So the key takeaways of today would be what is exciting about when these two giant, right? One in AI and GPU, and the other one on infrastructure virtualizations come together. And with the help of Tanzu, which is Kubernetes containers as well, how does it actually play a role in this whole AI and ML discussions, right? So hopefully this is the main key takeaway for today. Let's proceed on to our first slide, right? So machine learning, right? I think just to set the stage for everybody here on the call is that, machine learning, definitely is not new, right? We face this every day in our life, right? And since this is really, the last presentations of the day, I kind of want to make it into a more story mode, right? So to make it more vivid for you, as in how this can be so personal to each one of us as well. So, and especially myself, right? Going through some of these services myself, so I think I can explain it in a more vivid manner. So the first one is called the language recognition. This is not new, right? So you can see that when you call the banks, right? So they will ask you, to choose a few options. In the past, it has been very manual and kind of like pre-recorded, but these days they try to use the natural language processing to sense what are the keywords that you mentioned. And then they try to reply you using the words that you mentioned as well to make it more natural, right? So that is one key advancement when it comes to the language processing, but that is not all, right? Fun facts about how they have improved over the years, right? By using AI and ML on this automated response, right? Is that they are able to detect your tone as well. Are you happy with the responses so far? Are you kind of increasing your voice because you're thinking that it's taking too long for you to get connected to someone that you can speak live, right? So once they detected that, they will actually execute a series of actions according to their databases, right? So that is one of, I would say, the key applications when it comes to language recognition. It all started with natural language processing, but right now they're actually processing your tone as well, right? So interesting fact, number one, right? And the middle one is medical imaging. I'm sure, obviously, none of us really want to get into this and, have our X-ray being scanned, right, for whatever reason. But this is a key advancement in the human innovation history as well, right? So in the past, what happened is that you go to hospital, right? They put up an X-ray and say that, sir, give doctors a few hours to go through your X-ray. We're going to tell you the result, right? So what you can do is you wait outside and then the doctors will actually put on magnifying glasses and check every part of your bones, right? To make sure that it's okay. But with the help of AI and ML, this thing is semi-automated, right? So we have a very, very accurate processing software that you can feed the X-ray into that software and they actually scan through for any anomalies. They will highlight it to the doctors, so it saves doctors time and also be more accurate as well, right? To identify the issues on the bones. And that is also one key example in the applications of AI and ML today. And the last but not least is more dear to our financial institution, right? Because the frauds are happening every day, more so during this pandemic time, right? There's a very interesting statistics that says that, the fraud is actually 10 times more at least, right? During this pandemic period, because a lot of people are moving into the e-banking instead of walking into the physical branch. So this become more critical. So, one of the example of a fraud detection, right, is that, the banks knows your pattern of accessing bankings. So for example, if you are the person that always do your bankings on the weekdays, not on the weekends, and all of a sudden, right, you have one transactions or few transactions that is on weekend, at least the system will be able to flag it out through the fraud detectors, right? There'll be a team that's working 24/7 behind that is actually helping to monitor these kind of transactions. So at least what the system are able to do with the help of AI and ML is to say that, hey, you know what? Based on the past experiences, this person never accessed the banks, right, during the weekends, right? And never, more so, like transferring money out of the bank accounts. So the system is able to pick this up, alert the right departments, and the departments can act on it. Right? So these three stories, right, hopefully paint a more vivid picture for you of why AI ML is needed in almost every single business today, right? So the three examples here may be applicable for maybe more of phones, right, the call centers and medical industries and the banking industries, but there are just a lot more examples that I could not quote on this one slide, right? All of them are moving towards AI and ML to do a few things, right? We will be actually discussing some of these points later on as well. But one main thing is really to drive down the costs, increase the efficiencies, and bring up more revenue and business for the companies as well. Okay, so that's how important has AI become now, right? So I think this slide also correctly sum it up, right? The three key reasons are, again, drive cost reductions, because with the help of AI and ML, they can actually detect areas where you could cut costs. You could actually optimize the processes, right? Or you could just reduce some human capital and repurpose them to another usage, right? So that comes the cost reduction. And with cost reductions, that obviously also contribute to the revenue increase as well. That's number one. Number two, and you don't hear it from Daniel, right? You hear this from Gartner, because Gartner has actually interviewed a lot of the successful organizations that have implemented AI, and this is what they really told us. And it's rather new, right? So this survey was released in 2020. So if you're interested, you can just kind of punch it into Google, and the Google will actually show you where the list is. Number two, right? Coming back. Number two is competitive advantage. They are realizing that, right, by going on to this AI and ML journey, it makes them set themselves apart from their competitors, right? Just imagine, right, the examples that I was just giving you in the previous slide. If your company is implementing that, if your bank is implementing that, if your hospital is implementing that, the patients, right, or the customers would feel that you are actually quite cutting edge, right? You actually use technologies to help with the accuracy, to speed up the processes, and that also set you apart from your competitors as well. So that's number two, right? Do it faster, set you apart from competitors. And number three is, now this is interesting, right? I mean, for me, it's a good learning as well, right? So because after they interview so many C-level of the big organizations, so all the CEO, CIO, and CTO are saying that the board approval is much quicker with the AI tech to the solutions. And of course, the C-level understand this very well, right? With the AI and ML tech to the solutions, it will actually bring the benefits that we just discussed on point number one and number two. So hence, I think AI and ML is actually at the frontier. It should be on the frontier of a lot of the industries and businesses as well. Okay, so that's how important is the AI. Now, let's pivot a little bit, right? So hopefully by now you understand that AI is inevitable. AI is important for almost all businesses. But what are some of the challenges and barriers that the businesses are facing, right, throughout this journey, that some of the organizations still quite reluctant to actually move on with this journey or go full speed with this journey? There are actually quite a full list from Gartner, right? But I just extract the top three for the benefit of everyone here. And it's related to what I'm going to be talking today as well. Number one, right, shocking number is that, in another word, right, only 53% of the project related to AI and ML are successful to move into productions. So just imagine that 47% of time wasted, 47% of human capital wasted, money wasted, right? So this is actually quite shocking, right, in my opinion. Now, if we try to dig deeper, right, what could be the potential issues, right? There are two here that are equally very, very key, right? Number one is complexity of the AI solution integration with the existing infrastructure, right? So this shouldn't come as a surprise to you, because we all understand that the infrastructure has been here for the longest time, right? Maybe since like 20, 30 years ago, yet it doesn't really change quite a lot, right? From an architecture perspective, right? But from a general architecture, what I mean is that you need storage, you need compute, you need network, right? So that's very fundamental to all the infrastructures. But what is different right now is that AI ML, they require a different set of infrastructures. They require the resources that can be scaled up and down, almost in real time, right? Because the AI and ML, as the name speaks, right, is gathering a lot of data and they make the real-time decision on the spot. So the demand for the infrastructure is actually quite unpredictable to a certain sense, right? They sometimes require a lot more, sometimes they require a lot less. So the question here is, how do we actually optimize the infrastructures to cater for all the AI and solutions that we are going to implement? That will be the bulk of our discussion today, okay? The other one is security and privacy concerns. The more that you implement AI and ML, right, the question is, how do you ensure that the data that you have collected are secured and the privacies are intact? Because the last thing you want is like you could be very successful in implementing the AI and ML, and out of sudden the hacker got attacks to the infrastructures and gather all your user data or customer data, and the company got sued, right, because of the data breach or privacy concerns. That is the last thing on everybody's mind, right? So we need to make sure that the infrastructure not only can cater for the agility of the AI and ML workload, but it should also cater for the utmost security, right, for all the data that is sitting in the data center as well. So that is also another key reason that why people actually defer the AI projects, right? So if we kind of break it down, right? So just now you heard about just a bit more wider in terms of the data center and the industry issues, right, that the people are facing, that why are they not moving into AI and ML project? But as we talk to more data scientists and IT operators, these are what they say as well. They say that not only that, right, that but there are a few considerations that we are trying to take care, which is not actually accomplished today, right? So data scientist says, I need to experiment quickly, because AI ML is a model by itself, right? We need to improve the model from time to time, right? First time, the model, when we started the AI, could not be perfect, right? For example, when we teach the model how to answer the phone, right? It may not perfect at first because customer will throw all kind of questions to the AI model, right? After experimenting with a few models, that's how we get to roll out into productions, right? But throughout this process, the data scientist says that I need to experiment quickly. I need to test it. If I need to fail, I want to fail fast. That's one requirement. And the data scientists also say that from what they observe, right, it is rather complicated to scale the AI applications in productions. So why is this? Is also linked to number three. The point number three is a lot of the companies are still based on the ticket-based infrastructures. What does ticket-based means, right? I'll give you a clear examples, right? I've personally come across a few of these customers as well. Is that whenever they need the infrastructures, they will open up a ticket in their company, right? That's quite normal, right? So the ticket will take a lot of days actually, right? The ticket will first be, another sub-ticket will open to the network department and say that I will need this subnet to be provisioned. Another sub-ticket will be open to the storage and says that I need this storage to be provisioned, right? And another sub-ticket will be provisioned, another sub-ticket will be actually sent to the infra team to say that these are how many VMs I need, right? And these are the resources of the virtual machines. The problem with that is that you have a lot of dependency now, you see, right? And also, it will take a long time for all the approval to eventually comes in and also the provisioning to be done eventually, because all the provisioning are almost done in a manual way, right? In most cases. So to the data scientists is that I think it's a bit complicated, right? Because when I want to scale my AI apps, I'm talking about I need it almost now, immediately, right? And you're telling me that I need 1 week, 2 weeks to get it rolling. I think that's a bit too slow, right? So that's what data scientist says. Now let's pivot over to the IT operators, right? So we have to be fair, right? Because we have to also hear from the IT operators, right? The IT operators are saying that the current infrastructure's performance are unable to cope up with the AI apps requirements as well, right? As we all know that, AI and ML, as good as it sounds, right, with all the use cases that I mentioned at the beginning, imagine the amount of resources needed. So kind of going back to the medical imaging examples that I gave at the first slide, right? Just imagine how many X-ray images that you need to feed into these machines, right? And for these apps to process it. It's very heavy, right? Just imagine that, right? And we are not only doing that for one patient, right? We're doing that for a lot of patients, for example. So the existing infrastructure, how do we actually cope with this new set of AI and ML apps? Which lead to number 2, actually. Shadow IT is not new, right? I'm pretty sure that, a lot of the attendees here are familiar with Shadow IT, right? Shadow IT, if I put it into the layman terms, right, it means that the business units or the applications units, they are running their own IT or mini IT without the informations of the IT infrastructure owners. This is the same for AI. Because of the problems that the data scientists highlighted, and also the point that we just mentioned, right, the existing infrastructures are unable to cope. Hence, there is a problem of AI silos. What is AI silos? Which means the data scientists, sometimes they will just punch in 16-digit credit card to maybe some cloud providers and just spinning up their resources on the site, right? Now, while this is okay at first, but think about the security concerns. Think about the privacy concerns that I was just highlighting about. When you have this shadow IT or AI silos problem, it will go out of control very soon, right? Imagine all the business units are trying to do this themselves. So the IT infrastructure owner, right, the CTO or the CIO will have a big headache when it comes to the control and governance, right? Because everybody is trying to do their own things, and that is really the ultimate sad news about the shadow IT, right? So how do we actually address this? Last but not least, this is related to what I mentioned. When the AI silos happen, right, it's very hard for a company to ensure security and governance across all the infrastructure, because you are not even aware of some of the sub infrastructures that are being spun up by the business unit, right, to start with, but because they are doing their own things, right? So how do you actually ensure that the security and governance are there, right? So these are really some of the key highlights, what we heard from both sides of the fence. Okay, so I think hopefully these points are interesting, but not should be not new to you, right? And if we kind of put it into perspective as well, after what we hear from gardeners and also from our data scientists and from our data operators, right, we can kind of categorize it into 3, right? I mean, we want to try to stick to this rule of 3, right, so that everybody can kind of remember, right? So if this one, when it comes to problem statements, right, if there's one key takeaway, I would say it's this slide, right? Because it actually summarizes basically what we have been discussing in the past 15 minutes, right? So the number 1 is risk, right? If you are embarking on the AI and ML projects, we are talking about piece and parts that you need to pull together. So as the IT champion, I think it's quite stressful, first of all, and it has a risk as well, because it has a risk of not being integrated into the existing infrastructures, and the whole thing may just fail, right? The infrastructure are unable to cope as well, are unable to provide enough services for the AI and ML workload. So that's one. Number 2 is performance. I think we touched on this, right? I think it's expected. Like using the medical imaging example that we're just giving just now, just think about whether or not your infrastructures can cope, right, with the number of requests that are coming into the applications. The question here is, how do we scale our resources in order to support the demanding AI and ML applications, right? So that's on performance. And last is on scaling, which is related to performance as well. Because of the performance bottleneck, there is a need to scale. We need to scale out, right? Is there architectures about AI and ML that we can scale out easily? So when we need more resources, we just scale out. That will be the ideal state that we want to get into, right? So we are talking about sharing GPU resources while maintaining the manageability when we scale out, which means when we scale unlimitedly, right? So we just kind of keep on scaling out. At the same time, we want to ensure that the security is intact, the governance and control are still intact. We have control, we have full control about the infrastructures. So that's on scaling. Okay. So we speak about challenges, enough about challenges. So now it's about how we can help, right? So the good news for the industry, I would say, is that the VMware and Nvidia are really partnering up together in offering this kind of end-to-end AI enterprise architectures, right? You can almost look at it, right? Because I think as a service is kind of the in thing right now, right? You can almost look at this as AI enterprise as a service, right? That is offered by Nvidia plus VMware. we want to take away that complexities of, the underlying infrastructures, whether it works with the software stack or whether it works with the GPU, right? Away from the customers like yourself. You can leave this part to Nvidia and VMware, right? But what we hope that you can consume is that you take this full thing and just pass it to your data scientists so that your data scientists can just start writing some codes, right? To actually talk directly to the Nvidia AI enterprise SDKs, APIs, and framework and tool sets, right? That is on the top layers there, right? So if you look at that, Nvidia AI enterprise has introduced a lot of the tool sets, right? And SDKs and frameworks for the developers and the data scientists to use. And in the middle layers is where Nvidia and VMware work together to ensure that regardless of whether you want to run your AI ML workload as a virtual machines or containers, it should be seamless to the customers. It should be seamless because the last thing you want is like, oh, you know what? My data scientists come to me and say, I want a containers. And then we will go back and say, oh, sorry, because the current platform do not support containers, we will need to spin up another platform just for your containers. So now we are talking about two disjointed platforms to run literally the same thing, right? It's all for the AI and ML apps. But now you have two separate platforms, two separate management. We want to prevent that. We want to avoid that, right? And hence, this is also another reason of this AI-ready enterprise platform is that the vSphere with Tanzu actually offer a single pane of glass, right? A single management panel for you to manage the virtual machines and containers together as a whole. And management is just a starting point. There are a lot more to this, right? What about the lifecycle management? Can it be applicable to both virtual machines and containers? The answer is yes. What about my security and networking policies? Can it be applicable to my virtual machines and containers at the same time? Yes, the answer is yes too, right? So in short, they should be one-time setup, but applicable to both containers and virtual machines. There should not be a scenario where people have to tell you to spin up a separate platform just to run containers. So that's very, very key, right? And when we go down to the bottom, right, that's where Nvidia also play a significant part as well with their GPU innovations and also the smart NIC, right, or the DPU, right? These two, if combined together, offer a very, very high performance kind of a GPU acceleration for the applications, right? And underline that, right? So if you kind of move bottom, is that we want to be able to take this AI-ready enterprise platform and run it on the cloud of your choice. Okay? So you would see the words multi-cloud there, hybrid cloud is there, and private cloud is there. Key takeaways of this three is that regardless of which cloud is your choice, regardless of what cloud strategy that you have for your organizations, this whole AI-ready enterprise platform will run. So for this, I think the two companies have worked together, not just shook hands on the stage, right? The two CEOs, but also there's a co-engineering team internally in VMware and also Nvidia to ensure that this really works, right? We'll be touching a lot more key details later on, but I really just want to give you like a 30,000 foot view about why is this one slide about, this AI-ready enterprise platform about, okay? All right. So now I'll be going into like a bit more reasons so that you get to you get to see a bit more like kind of like the important key points, right, of how we actually help the customer run better on AI and ML. Okay. So there are really four kind of reasons here, right? Each of them will not be too heavy, right? I'll be touching on some of the key points for you to take away, but if we just kind of look at these four, right? Integrate AI with infrastructures is to prevent the AI silos that I was mentioning at the beginning, right? You do not want to have like another department spinning up their own AI mini infrastructures somewhere, right? But either buy their own servers and put in the garage, or either spin up another instances on the public cloud without the knowing of the IT operators. So how do we actually make sure that's integrated? That's very important, right? Second, accelerate development in a rapidly changing environment. as I mentioned earlier, right, a lot of the AI and ML workload are very unpredictable. So it is, if you ask any of the data scientists or data developers, right, their preference is to put it into the modern apps architectures. In short, containers, because that's literally one of the most modern apps architecture that you can ever get, really, right? So how does the infrastructures caters for the containers kind of an environment, and at the same time, right, be ready for the rapidly changing containers architectures, which means, right, because containers are slightly different from the typical workload or virtual machines, right, such as the Windows servers or the Linux. It will go up and down, right? Today, I need 2 containers. Tomorrow, the data scientists will say, I don't need any containers. And the day after, they will come and say, I need 5 containers, right? So how does the infrastructure keep up with that? We'll touch on that. Okay. Now to the top right, right? I think that one sounds like a fairy tale, right? When I first read it, right? I'll be honest here, right? So increased utilization without sacrificing performance. Sounds a bit too good to be true, but bear with me, right? I'll give you a couple of points of why this is really possible, right? Is that you really want to think about a lot of times, right? When you are buying the server with the GPU, the key questions that I always get from customer is that, how do I ensure that all my GPU on the servers are fully utilized? In another word, I don't want to have a problem of I have workload using one workload on one server are using all the GPU resources, while the other servers is having the GPU sitting idle, doing nothing, right? So how do we prevent that? So that's one way of increasing utilizations, right? And we want to do this without sacrificing performance, right? We'll see about that. And last but not least is scale for productions. So scale for production here is talking about how do I actually scale out, right? So let's say I started with a small AI and ML apps, but after that, I need to increase the size of the apps. I need to scale out to another cloud of choice as well. How do I actually do that? So we'll be talking about these 4 angles, right? Let's go into the first one. Now, the first one, right, to be integrated, I think we realize that the 2 vendors need to come together, right? One of the leader around AI and GPUs, and the other leader around infrastructure virtualizations and container virtualizations. And we as one team, right? And that's what we did with this AI enterprise platform, right? So to the customers, right, is that now gone are the days where I need to troubleshoot my Nvidia stack first, then after that I go to VMware and I will determine which one is the problems, right? Then I need to call the right numbers, making sure that I don't call the wrong numbers. Gone are the days, right? Think of it, the Nvidia AI Enterprise is like a service that's offered by Nvidia, right? So when you subscribe to the Nvidia AI Enterprise, you get a full stack, right? So the support will come from Nvidia. That's also the first touch point as well, right? You pick up the phone without thinking, you call Nvidia. Because this is a co-engineered solutions and both companies have invested resources in it, the handover will not be very awkward like what you would imagine with the multi-vendor, right? A lot of us are dealing with multi-vendors, so I'm sure you can relate to this, right? It's like, one vendor is trying to point the finger and say, why don't you contact the other vendor, right? So this problem will be significantly reduced because it's a co-engineered solution. So there's a co-investment, right? In terms of the people to help you to troubleshoot this whole stack end to end. In my opinion, this is one of the very, very key value proposition because it's just imagine myself as a customer, right? I really want to successfully run my AI and ML applications. That's all I care about, right? Leave the rest, right? Whether it is the toolkits, frameworks, whether it is the infrastructure layers, right? On the virtualized network, virtualized storage, virtualized compute, or whether it is the GPU and DPU utilizations. I really want to leave that aside. So a great news is that this framework and this offering does exactly that, right? It's actually offering you as a service, and the support comes from Nvidia, so you have sort of a single vendor of support as well, right? Throughout this journey. So with this, it actually ease the whole journey, right? So it is as integrated as you can imagine, right? It is a commitment from both companies as well, right? So to the customers, I think it will only bring benefits. So that's one point, right? And the other point is utilization without sacrificing performance, right? So I mentioned just now, it almost sounds like too good to be true, right? Or it's like a fairy tale, but it is not, right? So let's go down to the science of it, right? Or the scientific items of it. There are just really a few innovations that the both companies have worked together. Number one is what we call the Nvidia multi-instance GPU. vSphere 7 fully support this feature. And not only that, we also re-engineered two of the most famous features of vSphere to work alongside with MIG, right? It sounded like MIB, Man in Black, but it's not, right? So it's multi-instant GPU, MIG, right? In short, what you see here is that you have like one super powerful GPU that is impossible that one AI applications can fully consume it. So what do? You virtualize that, right? So you virtualize that GPU into multiple instances, and you can run multiple workloads on top of it. Why would you do this? This is to improve the utilization, because you don't want to have the empty GPU cycles, right? Sitting there idle doing nothing, right? By doing this, you could be optimizing your GPU cycles, right? And avoid wasting it. Very important. And the other way of looking at this, right, is the fault isolation. You kind of have maybe a few AI applications that are doing the same thing, but you want to split them up and using each of them using a different instance of the GPU. And the benefit of that is that if one of the micro apps fail, right, it doesn't affect the rest of them, right? So the rest of them are still functioning as usual. So that's also very important. Now, just like I mentioned that vSphere 7 also innovate two key features around this NVIDIA multi-instance GPU, right? Number one is vMotion, right? If you haven't heard about vMotion is, I think, the only reason why vSphere gotten so popular at the beginning, right? Is that instead of just, plugging the pen drive into another server and install the Windows server from scratch, we are talking about right-click, migrate, select the server, and then your virtual machine will just move there, right? So in short, with just a few clicks, right, you can actually move the whole workload from one host to the other host. In the past, it has limitation when it comes to the GPU kind of integration, right? Because as you can imagine, with GPU, there's a lot more dependency between the VMware stack and also Nvidia. But we have made it possible with the vSphere 7, right? So even if you run the multi-instance GPU, which means GPU sharing, you could actually move this workload from one host to the other host. So the benefits that translate to the customers or the end users is that it definitely prevents downtime, because vMotion is live, right? So vMotion is actually no downtime at all. So when you migrate, there is a technology that actually ensures that every bits and bytes also transfer across, right? So the workload continues to run while it is being migrated. So the supportability of this will ensure that your AI and ML apps, right, have no downtime. So that also increases the availability for your workload as well, right? So you then, of course, what you enjoy is the non-destructive maintenance operations, right? So imagine you need to bring down one host for maintenance. You could just vMotion that workload out from the host to another host. Then you can perform whatever maintenance that you want, right? Either changing hard disk or changing the NIC card or whatsoever, right? Just like examples. So that's vMotion. The other one is the DRS, right? So DRS is also another very, very key feature, right? That's why it got highlighted here. So what does DRS do? Is what we call the automatic workload placement. So just imagine, right? You have like multiple apps running on per host, right? What if there is one host that's being consumed more heavily than the other? So one host is, let's say, 90% utilized, right? In the worst case scenario. I think you don't want to go there, right? I mean, ideally, all the infra owners here would know. I think you try not to exceed 70%, right? So let's just say that extreme example, right? 90%. And the other host, right? The utilization is 30%. So is it possible that, somebody will smartly help me to move the workload, some of the workload on the very heavily used host to the more lightly used host? That's possible if you have the DRS set up. So DRS is always checking on the cluster, right? So you place a few hosts as a cluster, right? They will always ensure that the cluster is resource healthy, meaning that, if there is a host that's underutilized, they will try to vMotion, right, some of the virtual machines over, ensure that your clusters are even and balanced as well, right? So by doing this, right, again, your AI and ML apps will enjoy a very balanced performance. It won't be a time where, all the data scientists are trying to access into one particular apps they are running on one host, right? You actually crash the host because you're utilizing just that one host, right? Because the DRS would kick in, and then they will migrate some of the virtual machines to another more lightly used host, right? In order to spread out the consumptions. So in short, you avoid the performance bottlenecks with this feature. Okay. So hopefully, right now, you know that it's a science, right? It's really not a myth that, how to increase the utilization without sacrificing performance, right? And also, there is a benchmark being done as well. The reason why I put up this slide is very simple, right? Because I've gotten these questions from customers as well, right? So I just want to kind of demystify it right, for everybody here. One very common question is that, hey, Daniel, I was just thinking about this, right? If I were to run a GPU kind of workload or AI ML workload, right? Can I just run it bare metal? Like, I literally just install the whole stack on the host itself, right? Without virtualization. So, but take a look at this chart. So what this chart tells you is this, right? So if I were to summarize for you, is that if you virtualize or if you don't virtualize, the performance are almost on par. So don't be misled by the assumptions or the stigma that if you virtualize, the overhead is going to be killing you, right? Meaning that, you will lose a lot of performance when it comes to virtualizations as compared to just running it bare metal. So these charts will tell you that the performance-wise is very, very similar. I want to be realistic here, right? I cannot say that the virtualized one will run faster than the bare metal, right? Because I think it's just not practical, right? Virtualizations, you are installing a layer of software that helps you with a lot of other things, such as the vMotion and the DRS that I was mentioning about in the previous slide. So hopefully with the DRS and vMotion, you kind of see the benefits of virtualization, because just imagine, right? If you're not virtualizing it, if the host goes down, who is going to ensure that, the workload are being migrated to a healthy host? It's going to be a manual work. That's number one. Number two, how do you always ensure that the clusters are always balanced and healthy? Meaning somebody is actually helping you to migrate the workload in and out of the host, right? To spread out the workload across all the different hosts. Nobody is helping you unless you're doing it yourself, right? So that's also another key point that we have to take away, right? So, and the other thing is also the resource management, right? So from a management perspective, you kind of want to aggregate them into a single management so that you could actually create a clusters and say, name these the AI ML clusters, right? And you have all the different hosts running in on top of it. So that is your management as well, right? So this slide is really in summary to show that you definitely need to consider virtualizations when it comes to your AI and ML applications. Okay. There is the other thing that I want to talk about performance here, right? I know it's a lot of words there, but let's just focus on the middle graphic for a second, right? So what do you see on the middle graphic is that you see a GPU talking to a NIC card, and through the network going to another NIC card and talks to the GPU, right? So what does that mean? So that is what we call GPU direct, RDMA, right? It's a technology that gives you direct access to the GPU memory without going through the rest of the components of bottlenecks, right? The next one will show you in a better pictorial format. Take a look at this, right? So I'll give you like a couple of seconds to digest this, right? But it's not a rocket science. Without a GPU direct, a typical flow is that you have to talk to the CPU and you have to talk to the memory, right? These are the essential components of the cycles, right? Of how the batch are processed. But with GPU direct technologies, right? You're literally only channeling GPU traffics to the NIC card, And NIC card can go out through network to another NIC card and access the GPU on the other side. So what this offers you is that it takes away that bottleneck, right, from the rest of the components in the server to give you very, very good performance of utilizing the GPU memory. Okay, so that's one thing that is really, really key here. All right. All right, so the next one, we'll talk a little bit about the rapidly changing environment as well. So I mentioned that rapidly changing environment are closely linked to containers workload, right? Because today, a lot of the AI and ML, right, workload are actually going into the containers, as opposed to last time. Last time, the AI ML workload are also running in a very traditional application format, right? We use like C++ or .NET, right, to develop from scratch. So it's like a very big, applications that, you click compile, you need to wait for really like maybe like 30 minutes for the application to fully compile, right? So gone are the days, right? Today we are talking about containers where I just need a small little module that I code and I can compile it. I can run it as a container, and a lot of people can consume that container, right, to access the functions of the modules. And if I need to scale out, I will spin up another containers to bring the same set of code, right? So other applications can also access. So in short, right, so if you're not really very into technicalities of all this application development, in short, you can look at it as the AI and ML workload are moving towards containerizations. So what can we do to help? Oh yeah, actually, I probably should have shown this slide. I apologize, right? So this slide actually just speak about what I just talked about, right? Last slide is that, they're going through this rapid prototype concept as well, right? As I said, AI and ML needs to be continued to improve. It's not like one stable applications where we design and forget, right? So it's not like applications like, for lack of example, I'll just give one, like calendar, right? So the calendar applications on your iPhone or on your Android phone, right? You just access the calendar. It does really nothing more other than just showing you the date, right? And also maybe some more information on top of it. But AI and ML is different. We all know that, because every time you access the apps, right, they will learn something about you. After they learn something about you, they need to apply something new about you, right? They are consistently improving the prototype, right? And they iterate and iterate and iterate. So it's very crucial that, the underlying infrastructures can cater for the iterative nature of the AI and ML development, right? So let's see at the next slide, right? So this slide, I think I'll explain a bit, right? So this one is getting a bit more technical, right? But bear with me. Let me just kind of summarize the building blocks for you, right? So underlying, you have the software-defined data centers where VMware plays the strength at, right? So we have software-defined everything in VMware, right? So all the infrastructure stacks are virtualized. But that is not the key point. The key point here is by virtualizing your software-defined data centers, right? Now you are able to do a lot of logical separations of your workload that's running on top as well. And you would have realized that there is something called the VM services and also something called the Tanzu Kubernetes clusters. That kind of go back to the point that I mentioned earlier, if you still remember, is that there should not be a separate platform to run the virtual machines or a containers. It should be integrated as one. So in this case, we can look at it from a supervisor cluster perspective. And from a supervisor cluster, why is there a two supervisor cluster? Is that in most cases, you want to separate the development and also the productions, right? As an example. So all the services they are running, right, are all logically separated. In another word, your development, anything happens, right, shouldn't actually affect your productions, because the production is what you're offering to the customers, right? But because of the iterative nature of the AI and ML workload, they continue to improve it. So that belongs to the development areas. So the development areas need to be totally logically separated, right? But you also need to offer a bridge when you need to kind of push it to the productions as well. So that's why you kind of see a common platform at the bottom, which is SDDC, right? So SDDC means that your data center is fully connected on the software-defined level. Anytime you want to push from development to productions, right, is within a few clicks of mouse. It should be that way, right? Using the vMotion that I just mentioned about. That's one. The other thing is that, by running the virtual machines and containers side by side, right? The benefits that you get is that whatever that policies that you define under the SDDC, right? Be it the networking policies, security policies, governance policies, it should be applicable regardless of where your environment is or whether or not you want to run it as a containers or virtual machines. So this architecture does that, right? And this is what we have introduced with the vSphere 7 with Tanzu, right? So then that is quite a game-changing one, because in the past, even if you come to VMware for Kubernetes containers, we will tell you that you need to run a separate platform. That was before 7, right? But with the vSphere 7 with Tanzu, we will tell you that everything is integrated into the hypervisor layers, so that as a consumer, as an IT infrastructure head, you don't have to worry about, do I need a separate platform? Right? So it's all on the same platform, running on the common services offered by the SDDC. Okay, so that's a key takeaway about this slide. And last one, scale for productions. Today, right, it will be unrealistic if I just tell you that, hey, Mr. Customer, I think it's better for you to just stick with one cloud or stick on premise. You will say, I think, Daniel, you are dreaming, right? Because all the organizations are talking about, how do I leverage on multiple services on the multiple clouds? I'll give some examples, right? And this is a real example from one of my customers as well, is that I'm using AWS for most of my data warehousing storage, right? And the simple functions, right? Such as the web services. But I'm also using Azure for all other like a file sharing services, right? Through the Office 360 and all that kind of stuff. And I'm also using Google for data analytics as well. So in a world that we're living in now, right, is that when we talk about cloud services, we need to talk about all the clouds. It's no longer we talk about just one cloud, because we all know that each of the cloud has their own merits, right? And a lot of the critical workload are still sitting on premise for the obvious reason, right? Because we have got the data center premise that we have maintained. And we also maybe have some data locality requirements, the government regulations, the data sensitivity that require us to host it locally, let's say in Philippines, right? So how do I actually ensure that all these applications, right, or Tanzu, right, Kubernetes applications can run on this multiple cloud? So it is possible, right? So I think the key message here that I want to bring across is that, when you want to run your Kubernetes applications, and this can be AI and ML, and this can be non-AI and ML as well, think about a platform that can cut across multiple clouds, right? Don't try to just go into the platform that makes you lock into any cloud. Then after that, it will be very hard for you to scale out, right? So that's what we mean by scaling out as well. Okay. So as I promised, right? So I think this is going to be my last slide here, right? So 3 things, right, to take away is that, when we talk about AI and infrastructures, right, you want you to deploy with confidence, because these full stacks are validated and co-engineered between Nvidia and VMware, right? And it's fully supported by Nvidia, right? So Nvidia is the first point of contact. Be confident to deploy this, right? Gone are the days where you need to integrate all the bits and bytes yourself. That's number 1. Number 2, you saw my statistics on performance, right? It is significantly increased performance with the A100 GPU support on vSphere 7, right? So according to Nvidia, it's up to 20 times performance, right? And all these are not rocket science, right? It's utilizing some of the technology like GPU Direct that I was mentioning about just now, right? It actually offers the direct GPU to NIC card communications, bypassing the CPU and also memory. So that's number 2, boost the AI performance. And the last but not least is you want to scale without compromise. So how do I utilize all the GPU resources without wasting any of the cycles? The best way to do it is to virtualize and slice it, right? So once you slice it, you also kind of need to make sure that my workload has the mobility as well, right? I can move around from host to host, and also use the DRS for automatic placement. Which other host is more free? Then I'll move my AI workload there so that it's more balanced across from a performance perspective. All right. So these are the 3 key takeaways for my presentation today. Yeah. I'll leave you with this slide, right? So I think you can get this slide afterwards, right? So it's just some of the resources that you can refer to if you're interested to read more. All right. And with that, I will end my presentation.